Hey everybody, so we're here testing out the current rating of these screw terminals that are going to be used on the DC measurement board for the charger. I have it hooked up right now. This side would be negative, positive over here running through the current sensor. And it comes over to my little test rig. It's a 24 volt hydraulic pump motor from a battery operated forklift, and I just capped off the hydraulic line so it just builds pressure inside it. It's actually pretty hard right now, so that way it's just pumping into a heavy load. So we come over here and we got the motor controller, and it's hooked up to a pot on the bench right here, so I can just adjust current that way. And right here we got a 300 amp 5 volt power supply, so nothing that's going to shock you very bad, but still provide a good amount of juice. So and then I'm logging the whole thing on RTD here, and so I can check it out later. There we go, a little bigger. Alright, so controller's powered up, the board's in line. Like I said, here's motor negative, motor positive. Comes back, follow it back up here, right here, battery positive over to battery positive on the charger, motor negative out of the charger, down to the board. There it is. So, I'll pass through both the channels on the board. I'll turn it up now. I'll show you what it's at. So we're going to adjust the throttle until current feedback is 60 amps, because that's what we're looking to get. Oh, hang on a second. Gotta turn on the power supply. Forgot that. There we go. Alright, now we got some juice. Alright, so let's try this again. So you can see the screen there. Try to start your camera a little bit. Alright. So we'll turn up current. So there's 60 amps. 59, 63. It's bouncing around a little bit, but I'm commanding 57. And there goes the graph. So now we're pushing 60 amps into the load over here. I don't know if you can hear it, but it's ticking a little bit. It's trying to turn. So I did this test earlier. I ran it for about 3 minutes. The connectors did not get noticeably warmer at all. So the sensor, the blue sensor there, is a closed loop Hall effect sensor made by LEM. It's a LAH100P, so it's good for 100 amps nominal. So that's actually the limiting factor of what this board can measure. So what my goal was, since it didn't warm up at 60 amps, I was going to crank it up to 100 amps. And we'll see how well it does then. Alright, so now we're commanding between 98 and 100 amps. We're getting out right now 99, bouncing around just over 100 every couple seconds. Let's see, we're at 398 for duty cycle. And controller temperature's rising a little bit. We've already pumped in 1.2 amp hours. So it's using some juice. Let's go for a second. Now the pump's definitely, you can see the wires flicking around there. It's definitely pumping now. So check out the board. Here it is. And, this is 5-ounce copper on this board, by the way. So I'm just checking out the bottom of it, seeing what the copper feels like. It's all cold still. Terminals are still very cool. Might have warmed up a few degrees. But this terminal right here, it's actually still cooler than this crappy crimp. This thing's getting pretty warm. These came off of the same forklift that that pump came off of. That one's cool. That one's cool. That one's cool. So, none of the copper pads on the bottom of this are heating up. This one might be a little bit. So you can see on the bottom of it, this is one big pad that connects. I'll focus this. One big pad that connects the whole negative side, the input and the output, and it's bridged off for the voltage measurement circuit. Now on the other side here, you got your input over here and your output over there with the current sensor in the middle. So that one's a little bit warm, but very barely. This one over here, that one's cold. This one here, cold. This one here, cold. And the copper in the middle is still cool too. So I'm going to say the heat in this one is from this bad connection here. So, looks like that board would carry 100 amps. And we're still commanding 99 amps out of the thing. Let it run for a couple minutes, see how it does. Looks promising though.